All right, cool. So the title of this talk is The Cognitive and Social Correlates of Competitive Gaming Expertise. It's kind of a heavy title, but also very broad. So you will see a little bit more as we go on what exactly I mean by cognitive and social, why correlates is important, and what, within the field of competitive gaming, why expertise is interesting. So let's begin by defining expertise. In general, we're going to talk about expertise as defined thus: as in-depth knowledge in a specific domain. That knowledge could be literally memory, so knowledge of facts, events, etc., or it could be procedural, that is how to do something. In the case of competitive gaming, memory could be what stages are legal, what characters are your character good against, or procedural, how to do a wave dash, or how to execute a combo, that sort of thing. Expertise is having those skills. Expertise is having those skills and being able to execute them, more or less. So in terms of psychology, specifically cognitive psychology or cognitive science, there have been a lot of studies into expertise because they tell us something about not only behavior, but also the brain and the structure, internal cognitive structure of our thinking. So there's been a lot of studies about chess and how chess experts don't look at each piece individually, but instead look at patterns on a chessboard. And things like sports, how golf putters choke or don't choke, or how people execute free throws. All of those things are relevant to expertise and relevant to the human mind. So some things we've learned from them is that there are changes in cognitive architecture. So like I said, when it comes to chess, you don't look at individual pieces, you look at chunks. In esports or competitive gaming, that chunking might look like knowing that a certain sequence of moves is guaranteed to hit or is not interruptible. We also know that there's expansion of motor cortices in fine motor domains. What that means is whether you're a typist or a violinist, your motor cortex actually changes and expands in order to fit more information about your fingers and those fine movements. But when it comes to trying to study expertise in a scientific way, we can't exactly look at the brain or put your cognitive chunks or knowledge under a microscope. We have to look at it as the performance of that skill. So you can acquire the skill over time through practice, etc. But in the end, in order for me as a scientist to know how skilled you are, you're going to have to do it or perform, which is a different aspect that sort of complicates things. We've all been there where we've had a test, standardized test, and totally choked. Even though we knew how to do a math problem, we just blanked. And that's the kind of difference that performing a skill can make versus directly knowing someone's expertise. So where does expertise come from? How do we develop expertise? I mentioned practice, but there are according to the cognitive literature, there are 4 different aspects of this that are acquired over time. So on one hand, the idea of a 10,000 hour rule was popularized by Malcolm Gladwell in his book Outliers. And it's this idea that if you do something for 10,000 hours, you will be an expert. So whether that's running track or playing chess or anything, once you have 10,000 hours of practice, which is about 5 years, 40 hours a week kind of thing, you will be in the upper tier of performance. So that's a very heavy practice kind of explanation for expertise acquisition. Some psychologists have further extended this to say it's not just the 10,000 hours you put into it, it's not just the time that practice matters, but it's the quality of practice. You have to be deliberate about your practice in order to gain skill well. So for example, getting feedback versus not getting feedback could make a big difference in what your free throw is like or your putt. So deliberate practice is supposed to be guided, much more effective than just purely the time that you put into it. We can also talk about inborn traits or talent and how those things might affect not only how far someone ends up getting with their practice, but how fast they acquire skill. One example I love for this is Michael Phelps. So if you look at this picture of him, his anatomy is not like the average human. His chest is abnormally wide, his hands are abnormally large, his arms are long, and his legs are short. All of that makes him the perfect body type for doing a great butterfly, breaking world records for swimming in the butterfly, right? But, and not everybody is built like that, right? Like if I wanted to become an Olympic swimmer, I would never reach his times just because of my body type. What I do want to note is that when we're talking about video games, these bodily factors aren't quite as important. Video games are a little bit more arbitrary in that they require fine motor skill and cognitive talents. So we'll talk more about what I mean by cognitive talents, seeing as we're not talking about swimming or other sports. We're talking about electronic sports or competitive gaming, which are less reliant on somebody's muscle mass and things we know are correlate with gender differences and age and that kind of thing. So there's been a lot in the expertise literature about practice and talent, if only because they're easy to measure within one experimental paradigm, right? You can ask people to write down how many hours in the last week did you practice. You can measure somebody's hand size relative to their chest size. You know, you can measure those things a little bit more concretely, whereas motivation and access, although very important theoretically, are harder to measure in real world settings or even in a lab. But they're important because motivation, which is here in our talk defined as the forward motion towards expertise, aka conation, that motivation shapes how much we can practice, how much we rely on practice versus talent, and how much we care. How much we care and we want to get better, which makes huge differences in what kind of expertise we can acquire. On the other hand, access is something that we've talked about more in terms of social justice. If you look at financial resources, some people have access to the top gaming equipment, some people don't. There are things like access to other players or competitors. I grew up in a small town in the middle of nowhere, Missouri, where there really isn't a Smash scene. You have to drive half an hour to be able to play with other people. And that's different than someone who literally lives in a house with other Smash players, or esports players is what I mean. There's also things like family. So did you have brothers and sisters growing up that encouraged you to have certain interests? And also information. So knowledge about gaming in general, access to feedback, and the social benefits of pursuing any hobby, whether gaming or sports, is dependent on your social network and what other people in your life are doing. So although practice and talent are clearly very important, I also think that if we're going to try to describe skill acquisition, we need to be thinking about motivation and access as well. So I've already been dropping little things here and there about esports in particular as a high skill hobby, but I want to show you what esports is. So this is a picture of what many of us would look like if we were participating in an esport. Headset that we're talking into, over-the-ear headphones, mouse and keyboard, or controller. And I like this picture because it actually has a woman in it, which we will discuss is a rarity. So what about esports can we compare to past psychological studies of skill and expertise? So esports is computer-based. That makes it very easy to measure things like reaction time and collect lots of data because there's a lot of people out there using their computers to play these games. So very fruitful in terms of looking at real-world, large-scale data about expertise. Esports also have a high cognitive demand. So what that means is, in chess, you might take however long to decide on a move. In esports, you're basically playing chess where you're trying to predict what the other person's doing and predict what the best moves for you are given what pieces you have, but also in a very high-speed way. That means the brain is constantly, well, evaluating and making decisions about what to do next in a very complex environment. So high cognitive demand means that there are a lot of expertise-based things like chunking that will make a difference in somebody's play, and also potentially talent differences in cognitive skill. I also think esports is interesting because not only are you doing this constant decision-making, but you also have sensory motor demands that are happening. So whether it's keys on a keyboard or buttons on a controller, you are making split-second decisions and actually having to press the right buttons to execute them. What that means is those brain-based changes in sensory motor cortex are going to be really important and have to develop over time in esports. So esports are interesting because you've got high cognitive demands like chess, but also high sensory motor precision like sports or whatnot. Thus, it really is a very interesting field to be studying expertise or skill acquisition. What's also valuable about esports is that they are competitive. You either win or you lose. Your performance is very measurable by how many lives you lost, what percentage of health your opponent was at when they killed you, all those things. So it makes for very easy quantification for a psychologist because there's these numbers that clearly say you win, you lost, that sort of thing. So altogether, all of these skills to me show that esports is a very ripe field for studying expertise or skill acquisition. On top of the fact that esports is exploding right now in terms of popularity, in terms of potential. Lots of people growing up have been growing up on video games these days, and these esports, these competitive games, are going to also grow with that. There's also a lot of money going into esports right now. So it's a field that is growing very rapidly, which means we can really track how different people are gaining expertise. And as I mentioned earlier, esports are sort of arbitrary. That is, physical traits are less important to success. So obviously, if you don't have a hand, it's going to be harder to use a mouse. There are some physical things that will inevitably affect your esports performance. Other than that, though, a lot of what you're going to see in skill difference has to do with practice and with knowledge that you've acquired over time. So very easy to put basically any person into this skill training paradigm that is esports and be able to track their progress, whereas other people, or there might be limitations in skill for physical reasons in other fields. So in particular, there are many different esports. There are many different competitive games out there, Overwatch, League of Legends, all these big names. But the field that I've been studying, the game in particular, is Super Smash Bros. Melee. So Super Smash Bros. Melee came out for the Nintendo GameCube in 2002, I think. Anyway, it's been around for about 20 years. And what's interesting is that the developer, Nintendo, doesn't really support the scene, meaning that its entire growth and its entire status as it is now is based on the work of people, individuals that have been motivated for this long to build a scene. So it's a scene that's very near and dear to my heart. Also has a lot of problems because there isn't much oversight. But I did want to give you a sense of what this game looks like. You know, there are games that are shooters. There are games that are platformers. It's important to understand when we're talking about the expertise that we will, what skills might factor into this because of the game. You can tell already that there's some production value. And this is a video from EVO, which is one of the largest tournaments, just video gaming tournaments in the United States. At its peak, this match had over 200,000 viewers, and there were over 2,000 people in the stands physically there watching and cheering on these competitors. So you're going to hear some commentators giving play-by-plays, and you're going to see a lot of information displayed on the screen, but just hang with me. All right, so we've got two characters on the screen. Each person is controlling a different character, and they've got this flat stage where they're trying to approach or avoid being attacked by the other person. This was a very exciting match. You can hear from the commentators that there was a lot of backstory to this. And that's what I think part of makes what's Smash so special.